We'll go ahead and get started with the presentation today. First, we'll talk about InMage as an organization. InMage was founded in 2002. It was founded by a gentleman by the name of Kumar Nalabali, who was also the founder of Brocade Communications. We do have deep roots in data storage paths and in data protection now. InMage is a software-only company. It's dedicated to data protection, and that's all we do is make sure that we have software that will get your data from point A to point B, that it will be protected for any purpose that it's needed, whether it's a DR, system migration, or whatever that might be. Today we're going to talk about the Scout product. It has been available since 2003, and so we'll work through a couple different scenarios during our discussions today of Scout and how it can protect within your environment. We are based in the United States. We do have offices worldwide. There's several patents around the technologies in which we're going to discuss today. Some of the key ones are going to be CDP, or continuous data protection. We're going to talk about replicating between heterogeneous environments so that you can get into a DR facility and have that continuous data backup. We'd like to remind everybody that disaster is not necessarily that huge catastrophic event, not always the earthquake or the tornado or the hurricane that is taking systems offline. The majority of disasters are handled within the data center. Power failures, hardware failures, network failures, even human error. And these are the disasters that are typically seen as something that should, one, not happen and should be able to be recovered very, very quickly. InMage can help with any type of disaster, whether it's a catastrophic event and requires a full site failover, or whether it's just that one critical server that needs to be protected and ensure that it has the ability to come up very quickly. InMage is a network-based, block-level, asynchronous, continuous replication solution. What that actually means is network-based, meaning you do not have to make any modifications to your TCP/IP environment. We follow all the traditional TCP/IP rules. We are NAT enabled and compliant, and so you do not need to make any special accommodations just so you can have replication within your environment. Block level is dealing with the storage. We are working at the storage layer, replicating continuously the blocks and the changes within those blocks as they occur. So we're very optimized in that replication to ensure that not only do you have all the protection that you need, but it's very optimized in the amount of overhead from a bandwidth perspective to get that information to a remote site. Asynchronous, there is no distance limitation with InMage. Whether you're going to replicate to the cabinet next door or whether you're going to replicate around the world, it really doesn't matter. The process and the solution is the same for InMage. And it's continuous replication, meaning we're monitoring every single block as it changes, and we're only replicating the changed information within that block. So there's no such thing as a blackout window or a backup window or a bulk copy change or anything like that. We're simply monitoring the change as it occurs. We're keeping track of the order of change and the change rights and sending them to the remote site. InMage is the only unified software solution that's based on CDP, or continuous data protection, and focuses on 5 critical recovery challenges. It's recovering the data that's most important, especially in a disaster scenario. You want to make sure that that data is up in a usable fashion very, very quickly. It's not necessarily the backup that's difficult, it's the recovery of that data. So whether we're talking about disaster recovery, meaning a full site failover, meaning you need to have an order of operations in which those servers will come online. We can effectively bring that online in the appropriate order of operations. We can effectively do any combination of servers that you might have. Maybe it's all the servers need to come up. Maybe it's just tier 1 or critical application servers. We can help you manage that environment. We do have application availability, and we have consistency points within those applications. So when we're talking about application availability, InMage works with those specific applications to create consistent states. In a Microsoft world, we leverage VSS, or the Volume Shadow Copy Service. We do not deal with the shadow copy portion of VSS, but the very first step of VSS is to create a consistent state, or to flush down all the write I/O down to storage. And that's when InMage will then recognize which blocks have changed in order to create that consistent state, and it'll insert a flag or a marker immediately after that last block of change, and it'll remember when that consistency point was. So when it comes time to recover that data, you have the ability to recover your data down to the millisecond, and you can bring it online. You also have the option of recovering to a known consistency point, meaning that if it's a transactional application, SQL, Exchange, Oracle, SharePoint, whatever it might be, when you bring that online, it is in a production state. It's ready to handle production I/O as it occurs. Whether you're doing local continuous backup or whether you're doing it for recovery, it's the same solution. Backup and recovery is the same. Local and remote is the same. You're dealing with the same interface and the same technology to manage any type of backup and recovery scenario that you might have in your environment. Both backup and recovery for mixed virtual and physical environments. We can work with, on the physical side, we work with Windows. We work with several distributions of the Linux environment, Red Hat, anything Red Hat based, Debian, Ubuntu long-term, and SUSE Linux, to name a few. And within the Unix environment as well, we support many of the operating systems, HPUX, AIX, and Solaris are all available there. From a virtual environment, we do integrate with several of the virtualization vendors, the key ones being VMware, Citrix Zen Server, and Microsoft Hyper-V. And we also work with other virtualization vendors out there to a lesser extent. But we do have tight integration into VMware using some of the APIs that they've provided, as well as tight integration with Microsoft Hyper-V and Zen Server. We do have WAN optimization built into the product, so you can optimize the WAN, you can control the amount of bandwidth that's being used from a replication standpoint. You have advanced policies that can be set around the amount of bandwidth that's being used, whether you're need to facilitate a policy such as, during business hours only use, 40% of my available bandwidth, and after business hours go ahead and use 100% of that available bandwidth for replication. You can include and exclude specific servers in and out of those policies as well. And we also have SLA monitoring. Whether it's full site monitoring or whether it's on an individual server, we'll be able to provide you with graphical reports as well as text-based reports of exactly what's going on in your environment. We do provide you with a real-time RPO number, that recovery point objective, so you would know exactly how far behind each server or each volume within the server is behind in that replication. You could simply pull up a dashboard report in the UI and you could look and see, every one of my servers, it might be a minute behind, SQL might be 2 minutes behind, a file server might be 4 minutes behind, and you would know exactly how much data you would lose if you were to have an outage at that very moment. When you're talking about traditional CDP or continuous data protection, when you want to retain a long period of data, such as for a year's worth of data, typically it uses a fair amount of disk space to create that retention log. Again, we're keeping track of every single millisecond of change as it occurs, and we're keeping track of that in right order, so that when you want to recover to a point in time in history, we basically read that file in reverse and present the data as it looks at that point in time. So as you're protecting a long period of time, that retention log can become a fair amount of size, and if you're going to recover that data, it can take a fair amount of time to recover that data. So what InMage has done is we've introduced a technology called sparse retention. And essentially what it does is it retains fewer application points as the data gets older. So an example of what sparse retention might look like is for the first week, you want to have full CDP capabilities, meaning you want to be able to recover to any millisecond of time within that week's period of time. Then maybe for the following month, you want to recover on an hourly basis, or maybe it's a weekly basis. And then maybe for the remaining months up to a year, you want to recover on a monthly basis, or whatever it might be. There's 4 tiers of customization where you can deploy sparse retention to meet your needs. But ultimately what that does is it reduces the amount of data that needs to be retained in that retention log. And more importantly, it reduces the amount of time it takes to present data that's older. So you can realistically present data that's a year old in a reasonable amount of time to make it usable. InMage only replicates change blocks. We focus on keeping that RPO, that recovery point objective, very low. We also focus on keeping our bandwidth utilization very low as well. We packetize everything in 4K packets. It's very streamlined, very lightweight. And we can do that because we're only sending the changes within the blocks themselves. We're not even sending full blocks of information, just the deltas themselves. Because of that, there is no need for a deduplication product. There's nothing to deduplicate because we are already only sending the optimized changes to begin with. There's nothing that needs to be removed for optimization. So because of that, there's no need for rehydrating that data. In addition to that, because there's no need to rehydrate that data for recovery, it keeps that recovery time objective very low as well. Again, our focus is to keep that recovery point and that recovery time objective as close to 0 as possible. Many of the applications that we see are Exchange, Microsoft SQL, Oracle, SharePoint, MySQL, even BlackBerry Enterprise Server, as well as many other applications, and especially those in the Unix environment, we can have protection and application-specific support for to ensure that information can be protected. If there is a custom application that does not have the capability of creating a consistency point, we can work with the file system itself, and we can create consistency points at the file system level to ensure that we have protection of those types of applications. Typically, those are DB2, IBM Lotus Notes environments. Again, we're focused on keeping that recovery point and recovery time as close to 0 as possible. Some of the added benefits that we have that are included in the product is we have object-level recovery. So not only can we protect an entire server, not only can we protect an entire environment and help you bring that environment online in a DR location or bring that server online in a DR location and simplify the methods in which it can be used in a production state, we also give you the ability for object-level restore. A couple of them that we'll highlight are primarily is Exchange. So in Exchange 2007 and in Exchange 2010, we have our recovery manager for Exchange. It essentially allows you to present the Exchange mail store at any point in time, presents it very quickly, and gives you the ability to search and find and seek out specific messages. So you can find those specific messages. You can view them and validate that those are indeed the messages you're looking for. You then have several options, whether it's to export it in one of many mail formats or even in HTML format, or the other option is you can push that message back into the production mail store for that user. When you take advantage of that option, it simply takes that message or multiple messages and pushes them back into that mail store for that user. That user will simply see them in their inbox and be able to manage those messages as though they were never deleted in the first place. So you have full capability to restore at the object level with Exchange. We have similar capabilities when we're talking about file and database objects. We can recover databases, we can cover file servers, you can get down to the objects of the database, whether it's an entire table, specific record, information within a record. It doesn't matter. We have that capability that we can present the data using 0 additional disk space, and we can present it in read-write mode, so you have full query access to it. As we build out the next couple of architectural slides, the first slide here is representative of a physical environment and a physical environment replicating into a virtual environment that is a non-VMware environment. Essentially what we have is there are data tabs that reside on the servers. The piece of software, we have a host offload solution, meaning that there's a process server or a second tier of architecture available, and that process server does all the heavy lifting. Does the caching, queuing, compression, bandwidth management, reporting, everything that it needs to optimize that replication is done on that process server. The reason for that is we want to keep the agent extremely lightweight. It typically runs at about 1% CPU utilization during a write transaction. Other than that, it sits dormant. As we build out the secondary side of the target environment, it highlights our capability to do any combination of physical and virtual environments, whether it's physical to physical or virtual to virtual, physical into virtual, or whether it's virtual back to physical. Any combination of that can be replicated and can be protected and can be managed for a failover and a failback scenario. In the non-VMware environment, we do have the data tap deployed on the remote site. It auto-trains itself to accept the information and lay it down at the storage level, so you do have a block-for-block copy. We do have a control server on the secondary site that can facilitate the central point of management of all the process servers. So if you were to scale out and have multiple process servers or multiple sites that had a process server, you still have a single pane of glass to manage the environment. That control server also acts as a fail-back server, so that in the event that you do need to fail over into the secondary site, you have the capability to optimize your replication in the reverse direction for failback. As we build out this slide, it also highlights our many-to-one capabilities, where we can centralize for data protection, where you don't necessarily need that push-button failover failback, but you just want to consolidate data protection. You can consolidate down to a single server, has the appropriate amount of disk storage attached to it. You can then do some offloads to archive. For instance, if you want to archive it to tape, you could very reasonably do a weekly full or a monthly backup and simply have 30, 60 days worth of retention within InMage itself. As we get into the architectural side for VMware and specific VMware, in the upper left-hand side, we have a production environment. We have a physical server represented as a database server, as well as we have several virtual machines on our vSphere environment. In the lower right-hand side, there's your vSphere environment, and we do have a dedicated guest machine. We call it the vContinuum target. And essentially what happens is when you set up protection, you'll simply select the servers that you want to protect. We will then, if needed, push out the data tap onto those servers. The next step we do is we will take a copy of the metadata of those servers. In the physical server, we'll actually go through the P2V process of converting that machine into a virtual machine. Within the VMware servers, we'll take the VMX files and duplicate those VMX files on the target vSphere environment. We do give you the opportunity to update any metadata at this time. So if you want to change the IP address, you want to change the VLAN segment, the name, the CPU, memory information, like that, you're welcome to make those modifications at this point. We will then attach some storage to that vContinuum target. That vContinuum target will basically provision the appropriate amount of storage that's needed based on the servers that you're protecting. At that point, all of the block level replication will be centralized into the vContinuum target server. And the copies of the machines we made remain ghost copies, meaning they're there and available, but they're powered off and they don't have storage associated to them at this time. This is the state you would sit in to be protected, with the protected machines replicating down to the vContinuum target. When it comes time to recover a machine, you simply select the one or more machines that need to be recovered. The next step is you will roll back the storage to the specified time that you need, whether it's a known consistency point or whether it's a specific time. The vContinuum target will roll back the appropriate volumes to that point in time. It'll detach that storage and attach it to the target machine. It'll then power on that target machine and be ready to go. We do give you the opportunity to update metadata at this time as well. And essentially all you need to do is manage some network configuration, routing changes, and you have an identical copy of your server, operating system, as well as data log volumes available for you. And that's the process for recovering that in a VMware environment. We'll now hop into a quick lab demo where we want to go through and we'll show you the simplified user interface, and we'll actually go through a process of failing over a server and bringing it online very quickly. We just change the interface to our lab demo here. Okay, as this refreshes for you, you'll see the InMage web UI. We'll actually see some protection plans that are here in the middle. We're going to do an accelerated demo today because of the time constraints that we have, but we're going to work within this VM demo environment. We're actually going to work with the SQL Server that we have right here. We have SQL Server protected. You notice that it does have system volumes as well as data volumes protected here. And we do have our real-time RPO, and you can see we're very efficient and very low in the amount of data that we would lose in the event of a failure. So if I go ahead and minimize this screen, I'm going to bring up the vCenter just to give a quick look of what's going on in our environment. On the source side, this is the server that we're going to be failing over. It's that SQL Server. And we're essentially down below in the target. This is our ghost copy of that SQL Server that's being replicated to our vContinuum or our master target right now. So essentially what we're going to do is we're going to fill our SQL Server, and we're going to bring online our copy of our server and have it be in a consistent state. So in order to fail this server, I'm simply going to right-click on it. I'm going to power it off. I'm not going to do the shutdown or anything nice to it. We'll just power this thing off. I just created a disaster in the environment. We can no longer access that SQL Server, and it's time to recover that. I'm going to launch the vContinuum interface. The vContinuum interface is the interface that allows us to tie in APIs. I'll go ahead and select Manage Plans, and I'm going to select Recovery on the server. At this point, I can simply select the appropriate server that I want to recover. It is the Windows 2008 SQL Server, and I'll choose Next. When I select Next, the next is it's going to query the vContinuum master target, and it's going to collect information, recovery information, about this SQL Server. It's going to let us know how far back in time I can go. It's going to allow us to know at what points the consistency points are, and it's going to return that information to the system. Once that information is returned to the system, up here in the right-hand corner, we'll be able to select our recovery options. We have two quick recovery options, the first one being the last known good consistency point, or the latest tag. We can also choose the last known millisecond of data, or the last block of data that came in. And we can also select a consistency point within a specific time, or we can choose a specific time down to the millisecond as well. So once this information is returned, I'll select the last known good consistency point, and I'm going to choose Run a Readiness Check. What a readiness check is going to do is it's going to take the information I've selected, and it's going to validate that that information is accurate. If everything comes back accurate, we'll get a report saying that everything's successful and we can move forward with our recovery. If for some reason you've selected a point in time in which the information is not accurate, it will let you know that, and it'll also give corrective measures as needed so that you can troubleshoot any actions that you might need. So here you can see it's returned successfully to us. We simply give it a cosmetic name as far as a test plan, and I'll select Next here. The next screen is where I can modify the metadata if I would like. If I need to change the IP or anything, I simply manage that here. And finally, we go into our recovery scenario. We go into the recovery scenario. If I had selected multiple machines, they would be listed out here, and I could then modify the recovery order as needed. Because I only have one machine and I don't care about recovery order, I'm going to choose a WMI recovery, which is essentially a broadcast to recover that data as quickly as possible. Essentially what's happening, and what I want to do is keep an eye on the vCenter that's underneath. And when we go to that vCenter, what we're going to notice is in the task pane of that vCenter, we're going to start seeing some functions occur down there. And really what's happening right now behind the scenes is we've communicated to that vContinuum master target server. We've identified which volumes are associated to the SQL Server. There was 3 volumes there. And we've told the master target server at what point in time to roll back those 3 volumes. So we said go back to the last known good consistent state. So right now the master target server is doing that. It's identifying those 3 volumes that are attached to it, and it's rolling them back to that point in time that we've requested. Once that rollback is completed, it'll essentially detach those 3 volumes from the master target server, and it'll attach it into the SQL Server that we're trying to recover. And then ultimately, VMware will start that SQL Server. So if I grab my pen here, we'll be able to see that you'll see some tasks that are starting to happen down in the task pane. And the server that we want to keep an eye on is this SQL Server right here. Because ultimately what's happening is this master target server is going to remap the storage into that SQL Server. It'll go through its attachment process, and it'll ultimately power on that Windows machine, and that Windows machine will come online. As far as the speed of which that happens, it does not matter how much data, whether you're protecting 40 gigs or whether you're protecting 2 terabytes. The amount of time it takes to go through this process is the same. And what dictates the amount of time to bring that back in time has to do with a couple of things. It has to do with how far back in time you're going. So the further back in time, the longer it'll take. How busy is that server, or what is the transactional I/O on it? So the more transactions it has to undo. And lastly, it's the raw horsepower capabilities of that target server to process the information that's needed so it can present that data to us. If we were to stay on the vContinuum screen, we would certainly see an update as it happens right here. But ultimately, more interesting is to go to the vCenter, and let's actually open up a console in vCenter and see if we can see the operating system powering on now. So what we should see is Windows going through its power on process. You can see here, it'll be applying a few settings. And ultimately, when this is available, we'll be able to log in, and we'll be able to go ahead and pull up some SQL content, take a peek at it. While we give this a few minutes, let me review to see if there's any questions out there that we can answer. So one question that came in that we'll answer quickly as I log in here is it has to do with VMware and their copy on write API. We actually do not use the copy on write API with VMware. We're using our own technology to replicate that information. So ultimately what that means is you're not going to have a heavy or a large overhead within your ES environment. We are not duplicating the writes. We're not adding any footprint to your storage I/O. We keep that customized. You can see we now have the ability to log in. I'll go ahead and log into this server. And once we log in, the thing that you'll notice is we're actually going to go ahead and trigger the event prompt. And so you can log it appropriately if you bring this server online. You'll be able to keep track according to what the requirements are within your organization. And then now we'll simply go ahead and launch SQL. It's a little laggy because we're going through the VMware console, but nonetheless it'll show us that SQL Server will start up. We're essentially ready to accept and process write transactions at this point. And you can see SQL has started. It did not complain about any inconsistencies in the database. You can see we have a small database here with a couple of simple tables that we have here. I actually have a cheat file that I can pull out. It just has a simple select statement on it I can use. Let me go ahead and grab that. And remember, we failed over the entire server. So anything that has been done on the operating system level, as well as with the application itself, has been completely copied over in this failover. We'll simply highlight this simple select statement. We'll execute it, and you'll see that the SQL Server is responding, and we do have information in that SQL Server in right order. That's the process it takes to go ahead and recover using InMage within a virtual environment. We have the same process, whether it's VMware, Hyper-V, or Citrix Zen. We can do the same capabilities of recovery. The speed is essentially the same to bring that online. So let me look and see if there's any last questions here before we wrap up this meeting today. One last question that I'll address is specific to P2V, or physical to virtual. It wants to know if that P2V convert can be done in real time. And the answer is yes. You do not need to have a maintenance window to do the P2V convert. You simply establish that process and allow it to run during business hours or through the weekend. It doesn't matter. And essentially, we'll do that P2V convert. And then in addition to that, we'll keep track of all the changes that occur so that when you fail that machine over, not only is the P2V convert done, but we can apply any changes that have been made, and then we bring that online, just as we've done it in the lab here today.